This is the second lecture for Friday, April 24th, our second to last day of class, talking about humans and marine ecosystems. There's these two topics left to discuss, and then we'll be done, not just with this lecture, not just with this unit, but with the entire class. So this first question is, what do you do for improved management? If you recognize that there's this heavy fishing pressure on a few species, that there's a lot of species that are overfished, fished beyond sustainable levels, something like 70% of the population's different species around the world that are fished are overfished. And what kind of information do you need to manage a fishery sustainably? That's the question. The goal of most policymakers, most governments, whether you're talking about a federal government or some international agency or even a smaller scale like a state, is to fish marine resources sustainably. And that means that you're not taking out more individuals than the rate at which they're reproducing. So in other words, their population doesn't go up, doesn't go down. It might go up, but it certainly doesn't go down. That's sustainable fisheries. In the United States, the federal government decided years ago that all fisheries managed by the federal government should be fished sustainably by law. Most states follow the same guideline, that they're trying to fish these marine resources sustainably. So what do you need to do to know how many individuals in a population you can remove by fishing, and what rate that you do that? In other words, what kind of level of fishery is sustainable? Well, you need to know a number of different things, but some of the most important things in terms of a population, managing a population successfully, is you need to understand the life history of the different harvested species. You need to know basically how fast the population will grow. Secondly, it's a lot harder to get at, but it's also important in terms of managing the population, is what the population size is and what characteristics of that population are. Now, it's often very hard to understand the size of a population, but you can get an idea of the relative size of the population by comparing catch rates over time. For instance, you don't know exactly how many individuals there are, but you know whether the catch rate is going up or down or staying the same. And in regards to that, another thing is how many fish are being caught. Seems like it'd be pretty straightforward, but it's surprisingly difficult sometimes to quantify the number of individuals in a population that are being captured. So let's look at these different aspects of information that's very helpful in managing fisheries in a sustainable manner. First of all, life history characteristics. If you're trying to understand the rate at which a population increases, that's what's going to be balanced by the rate at which they're removed from the population by being caught, killed, eaten. Then you need to know certain things about that population in terms of how fast that population is growing. So let's look at some of those life history characteristics that will go into this. Basically, when fisheries managers, they calculate the rate of reproduction based on the age at which females start to reproduce, how many offspring they have in a reproductive event, how often they reproduce, how many offspring they produce during their lifetime. So those are some aspects in terms of reproduction. There's also survivorship of the young that varies quite a bit amongst the species. And that's going to tell you there's different sources of mortality. There's natural mortality from predators and not getting enough to eat and those kind of things. There's also fishery mortality. Those are things that you need to know as well. But in terms of life history characteristics, these are things that are going to go into models that are plugged into equations that are going to give you an idea of the rate of reproduction. How many young are produced within a certain amount of time? In other words, how much is the population increasing by the addition of these young to the population? So, how many offspring do you have? Do you have 1 million eggs? Do you have 5 live birth babies? How old are you when you mature? If you don't reach maturity until you're 25, that's obviously a different kind of reproductive contribution to the population than if you reproduce when you're 12. And also, how big are you when you reach maturity? It has to do with the size limits if you're establishing for different fisheries. If you're catching females that are all immature, or that includes immature females, that's going to have a different impact on the population than if you're restricting the size limit to females, especially females over a certain size. The frequency of reproduction. You may have 1 million young once, or you might have 100 young every 6 months or every year or every other year. And then this is what I was saying before, the mortality or the survivorship of young. Some of them are going to have a really high mortality rate, and other ones are going to have a much lower mortality rate. Survivorship is the opposite of mortality. Growth rate. It's tied into age at maturity and size at maturity. If you're really fast growing, then you have this life history characteristics that contribute to being able to withstand high levels of fishing pressure. If you grow more slowly, all of that's life in the slow lane, then you're not able to withstand heavy fishing pressure most of the time. Ultimately, though, is how fast does the population grow, especially in respect to how many individuals or what's the rate at which individuals are being removed from the population. This is individuals added to the population. What about the population distribution and movements? This is a very popular field of study. What kind of information does this convey and contribute to fisheries management or management of marine resources? Well, populations are managed based on stocks or subpopulations. So you might have bluefin tuna, for example, that are distributed all around the world. But if they don't mix very much between the Atlantic and the Pacific, then they're really two different populations, and they're experiencing different levels of fishing, they're experiencing different environmental conditions, their life history characteristics probably differ amongst the different areas. And so there's different stocks of bluefin tuna, there's different stocks of cod, there's different stocks of all these different fisheries, unless they mix very well. And so if you're managing a population, it tells you what kind of scale to manage that population. Sometimes there's multiple stocks of some species, and they need to be managed separately because they're not being fished the same, they're not having the reproduction, they're not adding to the population the same way with their life history characteristics. So one of the old ways of trying to see the extent of a population was to track the movements of fish by tagging them. So for years, 100 years, people have been trying to come up with fish tags. They put tags on their fins, they put tags under their skin. They've tried to come up with the different methods for tagging fish, keeping tags that are going to stay on them for a long time, dealing with the challenge of getting fishermen to report the captures when they catch a fish that has a tag in it. There's also, more recently, there's been development of using genetic markers to differentiate between populations. Different populations, subpopulations, are going to have different genetic makeup, and you can tell one population from another based on how much they mix, basically, which is going to be reflected in their genes. So here's an example of haddock. Haddock is a fish that you can find in the restaurants, you can find in grocery stores around here. So this is off the east coast of the United States. Based on genetic analysis and based on tag and recapture, then the fisheries managers have determined that there's 3 stocks of haddock. There's 2 main stocks. There's one in the Gulf of Maine, and there's one in Georges Bank. These are different stocks. They don't mix very much. They're managed separately. So they have different levels of fishing, and they have different levels of reproduction. So they have different life history characteristics that are building up the populations in different ways. So if you're looking at one of these stocks, for instance, let's say Georges Bank, you want to quantify the haddock population in Georges Bank, and you're differentiating this from the fish stock, the haddock stock that's in the Gulf of Maine, then you go out and you capture a bunch of fish, or these fish are captured in a commercial fishery. They're brought in, they're measured. You can do different things with them. You can see how big they are. You can look at their reproductive organs. You can look at what they're eating. And a very common thing is to try and determine the age of these by looking at their otoliths. And so here's an example of determining the age of the haddock that are captured and represented in this commercial fishery. And you can monitor this over time, and you can see what's happening with the population. So if you look at this figure with these circles here, there's the age classes. The bigger the circle, the more individuals there are in that age class. And you can see back in the 60s, there were a very large number of young haddock, 2- and 3-year-olds. That was the biggest component of the population. And there were quite a few big ones, all the way up to 9 years. By the 1980s, the proportion of 2- and 3-year-olds had shrunk quite a bit. And if you look at the 7-, 8-, 9-year-olds, there's hardly any. And you can see how this has changed over time. In the mid-2000s, this big component of the population of 2- and 3-year-olds was almost gone from this Georges Bank haddock stock. And so you can make projections of what's going to happen with the population going forward. You can use this information to manage the populations. Another important component for managing fish stocks is trying to estimate not how many new individuals are being recruited into the population, but how many are being captured. It's hard to do that, harder than you might think. There's a lot of different fish surveys that commercial fisheries have to report their catch. Every state that has borders the ocean has some program to census fishermen when they come into the docks. There's jobs that are available. People can get. I know students at URI that have gotten these jobs, where you go and you talk to the fishermen. Now, the fishermen express different levels of interest of talking to you, that sometimes they don't volunteer very much information. But this is something that is attempted in all these different fisheries, is how many fish are being caught. And then you balance that by the rate of reproduction. The population is building up at a certain rate, replenishing those that are being caught and killed. And the balance is this fishery yield, where the population is not going to go up and it's not going to go down. So for instance, here's a black sea bass in this picture. It's a common fish, a popular fish for eating in Narragansett Bay and around Rhode Island, up and down the East Coast, in fact. And so they're trying to estimate what's happening with the population. What is the yield, and is that yield sustainable? Is it going up or is it going down? So there's 2 different species that are shown here. There's this the black sea bass, and then there's this tomate. And if you look at the history of their catch per unit effort, C1 has dropped precipitously, and so that indicates that the population is a fraction of what it was historically. Even back 20 or 30 years ago, back in the 80s, this population was much higher, and it's been impacted negatively, and you have these catch rates that are very small compared to what was experienced even not that long ago, 30 years ago. And then you've got this other species where the catch rates have gone up, and there's no indication that this population is being overfished yet. All right, well, let's look to the future. A lot of people are interested in what is going to happen. Some people are pretty pessimistic. Other people are optimistic. Some people think, well, we're going to fish, and this fish that we're targeting is going to become so uncommon that it's not going to be economically feasible to target that fish anymore. We're just going to switch to some other fish. There's plenty of fish out there, and so that's how fisheries are going to go. So let's wait for the second lecture and turn our attention to that last topic, the future, not just of fisheries, but the future of relying on the ocean to provide resources, especially in terms of food, for humans moving forward.